Good afternoon, everyone. My name is Ankur Thatre, teaching assistant. I'm doing teaching assistant for the Microfluidic and Nanofluidic device uh, uh, course. The course instructor is Professor Suman Chakraborty from Department of Mechanical Engineering, IT Kharagpur. So today we are discussing about the life relationship, where we'll solve various kind of problems, previous mentioned assignments, doubts. So let's begin this today's life session. So first question I would introduce here which among the following statements E/R true regarding the optofluidics. So first option is only spatial control is possible. B is saying that only temporal control is possible. C is saying that both spatial and temporal control is possible. D is none of the above. So here the it's saying that the optofluidics first, it will be like both is possible spatial control and temporal control. As the option C is the correct relatively the both A and B compared to the both A and B. So here I say that option C is the correct answer. Okay, we'll move to the next question. Where the question is in optofluidics, flow is controlled by manipulating. So what options are A contact angle, B viscosity, C temperature, D all of the above. So what could be the answer here? Just try to guess this one. So their like answer is like option A, contact angle. So the flow is controlled by the manipulating of the contact angle. There is no relation between viscosity and temperature also. The next question is three different grades of filter papers, grade 1, grade 4, and grade 5 are being used in paper strips for point of care diagnostics. Which grade of filter paper will yield the co- fastest result if other design parameters and conditions are unchanged in the absence of aggregation, core blockage, or similar phenomena? Relevant data are given here. Grade and the average pore size has been mentioned in micrometers. Grade 1 has been given the average pore for grade 1, the average pore size has been given 11 micrometers. For grade 4, it is 25 micrometers, and for grade 5, it is 2.5 micrometers. So, the options are given here grade 1, option A is grade 1, option B is grade 4, option C is grade 5, and option D is all types of filter paper will be yield the result at the same time. So, please try to answer this question. Let's move to the answer side. So option C is the correct answer. So the solution is mentioned like filter papers are filter papers used in paper-based device have small pores a few micron in diameter. Therefore, capillary force is inversely proportional to the R. Is very strong, leading to the weakening capillary suction of liquid in paper devices. As the average pore size of graphite paper is less compared to the others, it will result in faster breaking. So that's why the graphite paper is the correct answer for this one. The next question is in which of the following application there is no role of bio-heat transfer. First is like option A is saying oral cancer screening at point of care. B is saying hydroelectric power plant on a paper strip. C is saying blood glucose monitoring system. D is saying plant on a cloth for harvesting electrical energy. So please try to choose the correct answer here. So the correct answer here are B, C, and D. So option A is saying that oral cancer screening at point of care. B is saying hydroelectric power plant on a paper strip. And C is saying the blood glucose monitoring system. There is the false answer here is a D. That is plant on a cloth for harvesting electrical energy. The next question is to determine the number of independent stress tensor components tau ij with the absence of any body couples. So here it is mentioned, option A is mentioned as 4, option B is mentioned as 9, option C is mentioned as 3, and option D is mentioned as 6. Please try to answer this one. So the correct answer is B. And how the values can be calculated? So the full solution is mentioned here. In the absence of antibody couples, tau ij is equal to tau ji. So the independent space tensor components are tau 11, tau 22, tau 22, tau 12 is equal to tau 21, and tau 23 is equal to tau 32, and the tau 31 is equal to tau 13. Therefore, the number of independent and space tensor components are 6. So 1, 2, 3, 4, 5, and 6. Total number of independent components are 6. Here, uh, the common data has been given for the question 4 to question 7. The, it's mentioned that considering the two-dimensional stress field as shown in the figure, the plane AA is cutting through the element at a 30-degree angle as shown. So it's mentioned like a sigma xx, sigma xy, sigma yy, sigma xy, everything is mentioned here, and this is the AA is mentioned here. The plane is cutting through this element, cutting at a 30-degree angle. So the question is determine the magnitude of shear stress acting on a plane AA. So we have to determine the magnitude of uh, shear stress. So it is given that sigma x is equal to 3000 Newton per meter square. Sigma yy is mentioned as a 2000 Newton per meter square, and sigma xy is mentioned 500 Newton per meter square. So the option A is saying that 2683 Newton per meter square. B mentioned B mentioned 1366 Newton per meter square. Please mention 5,366 Newton per meter square. Please mention 683 Newton per meter square. Please try to solve this question and let me know answer. So the option D is the correct answer here in this question. So the magnitude of CSS has been calculated using formula where this mentioned that tau x is 3000, tau sorry sigma x is 3000, sigma yy is 2000, and sigma xy is 500 Newton per meter square, and this is also sigma xy is also same 500 per meter square. To calculate the summation of the FC at AA, then it will come around, it will be around 0, which is equal to the tau AA L minus 3000 cos 30 and minus 500 sin 30 L sin 30 minus in bracket 500 cos 30 minus 2000 sin 30 in bracket close L cos 30. Therefore, the tau AA is around 683 Newton per meter square. If we calculate this one, then we get 683 Newton per meter square. The next question is to determine the magnitude of normal stress acting on the plane AA. It is given that sigma x is equal to 3000 Newton per meter square, sigma yy is given 2000 Newton per meter square, and sigma xy is given 500 Newton per meter square. Try to solve this question. The options are given as same as previous 2683 Newton per meter square. This is given as a 1366 Newton per meter square. This is given 5366 Newton per meter square, and this is given as 3683 Newton per meter square. Try to solve this question. The correct answer is A, and the detailed solution has mentioned here. The summation of the F and the normalized distress of A is 0, and this is equal to the sigma uh, AAL minus 3000 sin 30 plus 500 cos 30 L sin 30 degree minus 2000 cos 30 plus 500 sin 30 L cos 30, and after solving this the answer which is equal to the sigma A will be 2683 Newton per meter square. The next question is to determine the magnitude of shear stress of shear stress sigma x y, and it's given that sigma x is equal to 2000 and Newton per meter square, sigma y 3000 Newton per meter square. Sigma n normalized one is to 2500 Newton per meter square. Option A is given 434 Newton per meter square, B is given 289 Newton per meter square, C is given 577 Newton per meter square, D mentioned 1164 Newton per meter square. Correct answer is B, and the detailed solution has mentioned in the as mentioned below, which is saying that the sigma f n a is equal to the stress of the uh, xy we have to calculate. So sigma a is given like 2500 L minus sigma xy cos 30 plus 2000 sin 30 L sin 30 minus sigma xy sin 30 plus 2000 cos 30 L cos 30 is equal to 0. And after the solving this, the sigma xy we can calculate it, that sigma xy is equal to 2500 minus 500 minus 2250 divided by 0.866, which is approximately minus 289 Newton per meter square. So the magnitude of the shear stress in a xy direction is given as this right. So option B is the correct answer. Negative can be see, we are asking we are checking for the magnitude. So it can be positive and negative, so it will be magnitude will be in the positive one. Then the next question is to determine the magnitude of shear stress on the plane of plane AA. It is given that the sigma x is equal to 2000 Newton per meter square, sigma yy is given 3000 Newton per meter square, and sigma n AA is given as 2500 Newton per meter square. Option A is given that 434 Newton per meter square, B is given the 289 Newton per meter square, C is given 577 Newton per meter square, D is given 1164 Newton per meter square. Please try to solve this. So the correct answer here is C. And bigger question has been mentioned like this. The summation of Fc of A is equal to the tau AA NPL minus 2 in bracket 2000 cos 30 plus 289 sin 30 bracket close L sin 30 plus 289 cos 30 plus 2000 sin 30 bracket close L cos 30 is equal to 0. Therefore, tau AA is equal to 938 minus 1550 is equal to minus 577 meter per meter square. And magnitude we have to mention, so it will be positive, so the answer will be option. Let's move to the next question. The question is, uh, infinitesimally small fluid element is subjected to velocity k. U is equal to k plus in bracket x plus y. G is equal to k x minus y in bracket and w is equal to 0. So the question is determine the acceleration of the fluid element along x direction. The options are mentioned like A is equal to 2k square y, B is equal to 2k square x, C is equal to 2k square, C is equal to k square y plus k square x, and D is equal to c. Please try to answer this one. To answer the option, correct option is C. And then how we can calculate it? The solution has been mentioned that the acceleration of the fluid element along the x direction is given as Ax is equal to del u upon del t plus u del u upon del x plus u upon del y plus sorry del d del u upon del y plus w del u upon del z. If you see here, then we have the elements like u, v, and w. If you uh, uh, put the values at this place, u, this place, this place, and this place. Here also, we'll get this value. And then final answer, if you combine all this, then we get 2k square x, which is similar to the option B, and that's why our correct answer is B. We go to the same uh, parameters, and the question has been mentioned that determine the acceleration of fluid element along with y direction. So we have to uh, calculate for y direction. So the option A is correct for that. 2k square y, and the solution has been mentioned same here. So actually here there is a mistake, AY. So AY can be calculated using this del B upon del T plus U del B upon del X plus V del B upon del Y plus W del B upon del Z. And the individual indi differentiation will use this data. These data after combining it will be the option, the answer is option A. For same has to be applied on the Z direction and find out the acceleration for the Z direction. Just like this. So the answer is here option number D. And the solution has been mentioned as the previous one. So after putting all the values, the W value is around we'll keep the values, everything will be zero. And that's why the acceleration determinant, the acceleration in the direction will be zero. And here we'll wind up this lecture. Thank you so much for joining, and we'll see the next interesting, we'll see the interesting, more interesting questions in next week live session. Please join. Thank you so much for joining.